Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. Today we'll be doing, you have already seen this book many times. Okay, so today I'm going to start from exercise 8.1 uh, probability. We have already completed exercise 8.1, so I'm going to start with exercise 8.2 today. And 8.2 question number 1 is unbiased coin is thrown twice and its outcomes for each is recorded as H, head or tail. A possibility diagram could be drawn as shown. Now this is the possibility diagram. Now let me reproduce this diagram on my notebook, and to tell you that due to some unavoidable reasons, I am today the lecture is on your notebook, not on the whiteboard. Okay, now question number 1, 8.1, and question number is 1. 8.2 rather, it is 8.2 and question number is 1. So I have made this grid, and our question is, okay, I've already read the question before you, so let me read it once again. An unbiased coin is thrown twice and outcome for each is recorded as head, H, or tail. A possibility diagram could be drawn as shown. Now this is the possibility diagram. First throw and second throw. This is first throw and this is second throw. Let me rewrite these things over here. Now, my dear students, this is the first throw and this is the second throw. And of course, you know that for each event, either the head will be appearing or the tail will be appearing. So I write here head, tail, and head, tail. Now this is the first throw, and in the second throw maybe it will become head again. Okay, and on the first throw maybe it is tail, and in the second throw maybe it is head. In this first throw maybe it is head, and in the second it is tail, and in the first throw maybe it is tail, and in the second it is again tail. So this whole procedure is completed. You see that this is whole procedure has been completed, and the possibility table is completed. Once again, let me revise that maybe head will appear, maybe head will appear, maybe. The question was to complete this table. I've already completed it. Copy and complete the diagram. So we have completed this diagram. Now part B of the same question, question number 1, part B. Question number 1, part B is, and subpart A, 1, Roman 1, the coin shows the same face. Now you see the coin shows the same face. Here they shows the same face. Here no, here no, here yes. Now 2 out of 4 outcomes, 2 out of 4 outcomes are showing the same face in each of the throw or each of the toss. Now in the first toss and the second toss, the first two faces appear same, and in the first and the second last of the two faces, either of the uh, you see that these are two heads and these are two tails. So our question is same face. Now this is same face, this is same face. Now what we can do it now, the probability of same face, the probability of same face is equal to 2 divided by 4. That is 2 divided by 4, because there are how many outcomes? 1, 2, 3, 4, and 2 are of the same face. So it will become 1 upon 2. The probability is equal to 1 upon 2. Okay. Now question number 2. Now the second question is that the coin both shows head. Now there is only one possibility that both the coins are showing one head. Okay, same. So it is both heads. that is equal to 1 upon 4. Simple. There is only one possibility, that both heads have been appeared. Here one head has appeared, here one head has appeared, and here no head has been appeared. So there is only one possibility, that 1 out of 4 are the heads. Now question part 3 of the same. You see that there is at least one head. There is at least one head. Now you see that there is one head. At least one head is here. At least one head is here. At least one head is here. So at least one head. One head. Now this is one head. One head, that is equal to, you see, there are 3 possibilities in which at least one head has appeared. So 3 divided by 4 is our answer. In this event, at least one head is there. There are both the head, but at least the question asked us that at least one head. So there is at least one head in this event also. There are no heads. There are no heads. You see that there are no heads. No heads. No. No heads. No. No heads. No. No heads. Yes, there is one possibility that it has no heads. No heads. So it is equal to 1 by 4. So my dear students, uh, our question has completed. Now you see that it is the part 1 is. Now let me check the answers. You must always study the answers before you proceed. So my dear students, the answers are, okay, this one was correct, and all the answers are correct. Okay, my dear students, now I can proceed to the question number 2. Now, my dear students, 2 dice are thrown and the product of 2 numbers is recorded. Draw the possibility diagram to show all possible outcomes. Find the probability that. Now let me draw 2 dice. Now you see that dice, when you say a die has 6 faces unless and until it has been specified specially. Unless and until it has specified specially, the dice has 6 faces. In the question, maybe in the preceding questions, we may be tackling some dice which have more than 6 faces or less than 6 faces, maybe. Okay, so unless and until it is specified, the dice has 6 faces, and you play the games with dice. Okay, now let me do this question number 2. Question number 2. Now let me draw the grid first. Okay, then I'll come back to you. Now this is a table of 7 by 7, because uh, in in two of in one of the row. Now these are the rows. Okay, these are the rows. You may be using uh, Microsoft Excel. Now these are the rows and these are the columns. Okay, these are the columns and these are the rows. So what we have to do is we have to write here 1, 2, 3, 4, 5 and 6. Now I am going to put some mark because these are the headings. These are the headings, okay? And 1, 2, 3, 4, 5 and 6. These are the headings. You can write it in another color, or you just be sure that these are not counted in your rest of the questions. Now what is the question? Now we have to multiply them. We have to multiply them. Okay. Now 1 times 1 is 1. Okay. 1 times 2 is 2. And it will be written as it is. As it is. Because 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 1 times 5 is 5, 1 times 6 is 6. So that's why I have just marked these short lines to just to make it significant that these are not in our product lines. Okay, now these are the product lines. Now 2 1 times 2, 2 2 times 4, and similarly 6 8 10 and 12. You are following that. 2 6 times 12, 3 1 times 3, 3 2 times 6, 3 3 times 9, and 12 and 15 and 18. And my dear students, fourth, 4 1 times is 4, or you can say simply that these are the multiples of each of the following numbers, each of the numbers. Okay, now these are the multiples. 4 1 times 4, 4 2 times 8, 4 3 times 12, and so on and so forth. Okay, 20 and 24. Okay, 5 1 times, 2 times, 3 times, 4 times, 5 times, and 6 times. Similarly, 6 1 times, 6 2 times, 6 3 times, 6 4 times, and 6 5 times, and 6 times. In fact, our outcomes are, how much outcomes are there? There are 36 outcomes. Not because of this, not because of this 36, but you can count the grid: 1 2 3 4 5 6, 1 2 3 4 5 6. Now these are 6 by 6, and 6 by 6 is 36. Okay, 6 by 6 is 36. Now first question is, this is question number 2. Question is that the product is 1, that the product is 1. You see that, that's why I have just marked these short lines. Understanding my point now? Now the only answer is this. The only answer is this. Out of 36 outcomes. Now out of 36 outcomes, the only answer that the product P is 1. P is 1. That the product is 1 is equal to 1 divided by 36. This is only answer. This is the only answer which will satisfy our productivity. Paramba dika dika te dimba dimba dimba. This which will satisfy our possibility and probability. Okay. Now the only answer is 1 over here, and it is amongst 36 outcomes. Okay. The total outcomes are 36. The desired outcome is only 1, and by chance the number is also 1. The higher number is odd. Okay, not this is not the product is 7. Now part 2, the product is 7. P, the product is 7. Product is 7. Now how many possibilities are there in which the product is 7? And to tell you that there shouldn't be any possibility that the product is 7, because this table does not belong to 7. From here and from here, okay, this does not belong to 7. Therefore it is impossible to have 7 as a product. 7 has a product. You can also see it that there is no 7 in the whole table. There is no 7 in the whole table. So the product, the possibility or the probability is 0 upon 36, and the outcome is 0, and the outcome will be 0. Now my dear students, let me proceed to question number 3 now. 3, and which is what? Here you. Okay, part number 3 is the product is less than or equal to. Okay, now less than and equal to. This is less than and this is equal to, and the question is about 4. Now you see that in this vicinity we don't have any 0. We don't have any 0. we have 1, we have 2, we have 3, we have 4. That means 1 to 3 are 1 to 3 satisfy this symbol, and only 4 satisfy this symbol, because this is equal to also. This is equal to. So that means from 1 to 4 we have to take from 1 to 4. So let me write this symbol again over here, is equal to this. Okay, now this is equal to, how much are there? How much are there? Now we do have 1, 2, 3, 3 over here, 1, 2, 3, 4 over here. Okay, we have 4 over here, 4 over here, 1, 2, 2 over here, 1 over here, 1 over here. So what is the, let me check, 1, 2, 3, 4, 2 and 4, 2, 3, 1, 4, 1. Okay, the total number is 8. Now it will become 8 upon 36. Okay, now 8 upon 36, just simplify this it. 4 2 times 8 and 4 9 times. So it will become 2 divided by 9. 2 divided by 9. Probability will be equal to 2 divided by 9. Now part 4. Part 4 is the product is greater than 4. Of course, we have already taken up till 4. We have taken up till 4. There were 8 events. And the rest of the events, there are two or three ways to find this part, but the easiest is that you can do that. P is greater than 4, so that is equal to, so this is less than 4 or equal to 4. That means up till 4 the probability is this, and therefore 1 minus 2 upon 9 should be the probability that these are greater than 4. So now this is one, and the other is that you just minus 38 from 36. What will it become? It will become 28. Now it will become 28. Okay, so it is 28 divided by 36. 28 divided by 36. You can simplify it 4 times, 4 7 times, and 4 9 times. This will become 7 upon 9. And what about this? 9 minus 2, 7 upon 9. Again 7 upon 9. This is 7 upon 9. And the last method is you just count. Then again it will become 28. Okay. Now there is one left, I think. There are two left. Okay. Now part 5 of question number 2. Now part 5 is the product is a prime number. The product is the prime number. P is prime number. Okay, that is prime number. Now you know the prime number are started from 2. The minimum, the smallest prime number is 2, not 1. I have told you many times. Now just look at this now. Okay, now I'm going to erase this because this was the older. So 1, this is prime number, this is prime number, this is prime number. Okay, 2, 3, 5 are prime number. So there are 3 prime number in this row, 1 prime number in this row, 1 prime number in this row. Yes. Okay. One prime number in this row. Okay. Now there are how many prime numbers? 5 prime numbers. 6 prime numbers. 3, 4, 5, 6 prime number. There are 6 prime numbers. That means our probability will be, the product is, prime number is 6. That means that is equal to 1 upon 6. Okay. Excuse me. Now part last. This is sixth part. Now the last part is about the square numbers in this probability diagram. Okay. Now probability diagram. You know that 1 is also the square number, because, let me explain it to you. 1 multiplied by 1 is 1. Okay. So the product of the same number is the square number. Okay. Now back to the table. Now there is one square number, two square number. Okay, there are two square numbers. Most of these square numbers will lie diagonally. You see, here from here to here, but there are some more. Okay, 1 4 1 9 1 4 again, and 16. There are two. One is 4 and 116. 125 and 130. Okay. Now there are 2, 3, 4, 5, 6, 7, 8. There are 8. Yes, there are 8. The probability of square numbers is 8 divided by 36. Okay. 8 divided by 36. Now by simplifying 4 2 times and 4 9 times. Now this is the probability 2 upon 9. Now let me check your answers, because I am doing it for the first time. Okay. Now question number 2 part, question number 3. This was question number, yes, it was question number 2. So this is correct. This is correct. 2.92 divided by 9 is correct. 7 divided by 9 is correct. 1 divided by 6 is correct. Okay, this is correct, and this is also correct. Okay, now let me proceed to third question. Now let me proceed to third question. It is very interesting question. Now, as I told you that you will be facing the dice with less than 6 faces or more than 6 faces. Now here there is a spinner, is a pentagonal spinner, if I can make it correctly. Almost I have done it. Okay, I have almost done. Now this division is called the umbrella division, as I earlier told you that this is called the umbrella division. Like this is like the umbrella. Okay, and there is one tetrahedral also. Uh, tetrahedral is uh, tetrahedral is a geometrical shape with 4 triangles. Okay, this is equal to 4 triangles. This is called, now 3, you can see the 3, and 1 is behind these. Okay. Now 3. The diagram shows the spinner with 5 equal sectors number 1, 2, 3, 4, 5. Now, this is numbered 1, 2, 3, 4, and 5. Okay. 1, 2, 3, 4, 5. Now, this is question number 3, my dear students. Question number 3. And the question states that there is a spinner. Now, this is a spinner. There is a pointer over here. Okay. When you spin it, any face will come against this pointer, and you'll note. Now let me read them. Now in the tetrahedral there are 4 faces: 2, 4, 6, and 8. 2, 4, 6, and 8. 4, 6, 8, and 2 is behind the scene. 2 is behind the scene. Okay, I am writing it over here. Now what does he says? Draw a possibility diagram to show the possible outcomes. Now what are the possible outcomes? What is the condition of the possible outcomes? The condition of the possible outcomes is that we have to record the higher numbers. We have to record the higher numbers. Now there will be 5 rows over here or 5 columns, and vice versa, 5 rows or columns. From at one side we'll be showing column, and one side will be showing rows. Then we see that how. Let me make the grid first. Okay, now this is the table. I call it grid sometimes. Now we have to record the higher numbers over here. Higher numbers. Okay, now let me take the die over here. It is your own will that you take die over here, you take die over here, you take spinner over here, or you take spinner over here. There is no condition that you have to take very specifically the die over here, or spinner over here, or spinner over here, or die over here. There are no conditions. Okay, now this is spinner. Okay, spinner. Now spinner has how many faces? 1, 2, 3, 4, and 5. And die has 4 faces from 2, because 2 is hidden. 2, 4, 6, and 8. Now if both are thrown together, that means if it is spun and it is thrown, it is spun and it is thrown, then we have to record the higher number out of it. That means, for example, 1 came on the spinner and 2 came on the dice. Then we'll write here 2. Again, on the second round, if 2 appears and here 2 appears, then it means that 2 is the higher, because both are the same. And similarly, 2 and 3, 3 will be recorded. From 2 and 4, 4 will be recorded. 2 and 5, 5 will be recorded. Similarly, 4 and 1, 4 will be recorded. 4 and 2, 4 will be recorded. 4 and 3, 4 will be recorded. 4 and 4, 4 will be recorded. 4 and 5, 5 will be recorded. Okay. 6, 1, 6 will be recorded. 6, 2, 6 will be recorded. 6, 3, 6 will be recorded. And I think 6 will be recorded in each event now in this row. Okay, and 8 will be recorded in this row, because 8 is greater of all. 8, 8, 8, 8, 8. Okay, because 8 is greater than 1, 8 is greater than 2, 8 is greater than 3, 8 is greater than 4, 8 is greater than 5. Now coming up to the question. Now the question says, now this is the part A. Part A is completed. In part B, calculate probability that the higher number is even. That the higher number is even. PE. So even. Part B, sub part 1 is even. Now you see that how many even. Now again put some dots over here. Put some dots that these should not be counted. These are the headers. These are not to be counted. Okay, these are not to be counted. This line is not to be counted. This line, this column is not to be counted. Okay, now there are how many even numbers? 1 2 3, three even numbers over here. 1 2 3 4 even numbers over here. 1 2 3 4 numbers over here. 1 2 3 4 5 numbers over here, and 1 2 3 4 5 numbers over here. Now how many total outcomes are there? 1 2 3 4 5, 1 2 3 4. There are 20 outputs. Okay, there are outcomes, 20 outcomes. The total number of outcome is total number of, I will tell you the way how we can calculate the outcomes. Total number of outcomes is equal to 20. Now the even is, that is favorable outcomes divided by total number of outcomes. Total number of outcomes or total outcomes. Now favorable outcomes are how much? 10 and 17. There are 17 favorable outcome out of 20. So this is the probability that this is the even number. Now B part is B sub part 2 is almost the same. It was even, now it is the odd. Okay, now you will you will just count the odd numbers from here, and then you will write the favorite outcomes divided by that will remain the same, because it is 20. Okay, and the higher number is multiple of 3. Number 3, the higher number is multiple of 3. Okay, the multiple of 3 means 3 itself is 1 2 3 4 5 6. 2 1 2 3 4 5 5 are here. Now there are total, yes, 6 multiples of 3. 3 itself and 5 are here. Okay, there are total 6 divided by 20. Okay, it will become 3 upon 10.